So till now we have considered all the modules which were important. One of the heavy module which is remaining is the air handling units. So different types of air handling units and the components like furnace, boilers, fans, coils, valves, etc. But let's for this video focus on one of the very unique thing, a unique concept which we and everyone in the industry uses it extensively, which is called as zoning. So earlier when I explained you the steady state building load calculations, what we assumed was, let's say we have a building given. So and the different types of loads which were acting on the building were like solar, electric or internal heat gain, occupants, solar transmission, and the conduction or transmission. Which also includes the infiltration load. But while we consider the whole building as a whole and used all these factors, what some of the factors we wanted was average occupancy in the building or average amount of electrical like appliances or lights used, and the whole building as a whole we consider for the solar loads or solar transmission or infiltration and the actual transmission from the walls. But that will give me a very bad estimate. So let's assume that we have a very large building. Usually in large buildings the case is that there are a lot of people, so the surface area doesn't increase as much. We know that the surface area increases by a factor of 2 while the volume increases with the factor of 3. So side cube. So the volume increases too much, hence the space which has electrical equipments and occupants are increasing much more, and because of that reason the internal heat gain is very high. The internal heat gain is large, and this makes us believe. So if we calculate the balance temperature is the temperature when there is no net heating or cooling requirement, and because there are a lot of electrical appliances and occupant inside, the internal heat gain is so large, and hence the balance temperature goes very low. That means that even if the outside is very cold, the internal heat gains are large enough that the building remains heated up enough or warm enough or comfortable enough that there is no virtual or actual heating requirement for my building. So because of large internal heat gains, my balance temperature is low, and because of low balance temperature, it says that on average, because we had considered all the loads on average, I'm continuing with that term and stressing on it because that's where we are going to make a change in zoning. So on average there is no heating requirement, and the balance temperature could go as low as 0 Kelvin, and that means that even if the outside is 0 Kelvin, that's really very cold, but the internal heat gains from occupants and occupants and electrical appliances are so high that there is no heating requirement even if outside is 0 Kelvin. That is actually not the case. That is a bit of misleading, because let's say if these are walls and there is office is over here. So let's say at the ends on the boundary these are office everywhere. Internally we have some hallway over here. So this is the hallway. And again in here we may have some conference room or break room or something. Sorry. Or we can again have some classrooms, offices, anything. But when we consider this as the actual, like this could be one of the actual building, and in this case, even if outside it's not, let's say it's not 0 Kelvin, it's 0 degree Fahrenheit, which is like minus 15 degrees Celsius or something. Let's say this is the temperature outside, and hence we are sure enough that from the walls we'll be losing heat. So if there is a person over here working and his office is like this, a small space which has a door, and the door is obviously very close, hence the internal heat gains for this small office will not be very high. If we consider the whole building internal heat gains, it will be large, but for that small office it would be low. And there is a wall over here from which there will be a solar transmission load. That means because of the temperature difference, inside we may have a temperature of 22 degrees Celsius, which is the comfortable temperature, and outside is minus 15. So because of that, we'll be losing heat. The building will keep losing heat, and there will be a heat transfer from inside to outside, and obviously this heat transfer will be considerably high, and hence we'll be losing heat from the room to outwards. And the time, as the time goes by, this temperature will drop. But when we do all the analysis on an average loads, it says there is no heating requirement, but eventually this room will require heating. Hence, this is an anomaly. This is a problem of considering the average loads. When we consider the average load, we do not get the actual requirement of a room. We are getting an overall requirement of the whole building. So the better version or better model of the building could be, when we make a building like that, and let's say there are offices. Sorry, I'm not very good at drawing. We'll consider separate zones. So these are the 4 zones. These are the walls and all, outside boundary, peripheral. So now what we'll do, when we do the analysis or when we calculate the loads, we'll calculate the loads separately for this zone and do the analysis for temperature and cooling or heating requirement. Hence, this small zone will have its own electrical occupants considered itself in this zone, and these zones will not be contributed or calculated in this. So what's happening is, we are having a more closer estimate of the actual heating or cooling requirements. Now we knew that this zone will require the heating or cooling. This will require the heating in the winter seasons. So if we make a zone like this, we'll now know, if we find the balance temperature, the balance temperature could be 0 degrees Celsius. So if my outside temperature is less than 0 degrees Celsius, this specific zone will require heatings. So when the outside temperature goes below 0 degrees Celsius, this zone will start require heating. But when we did the actual analysis, taking whole building as an average, the balance temperature could go as low as, like, let's say minus 15 degrees Celsius, or let's say minus 100 degrees Celsius. So that's not the actual estimate. This is a more closer estimate. So now we know that this zone will start requiring heating. While this zone, because it is not having as much solar gains, so this zone might have solar gains, might have infiltration, so which will lose some hot air from inside because of some window cracks, leaks, etc. This zone might require cooling. Even in winter, because it is an internal zone and it has a lot of electrical and occupants, because the space is large enough and there is no way it is going to lose heat to outside. There are no walls, there is no contact from the internal zone to direct outside. These zones are having an outside direct contact from the walls, but this zone is internal zone. So the interior zone might require cooling even in winter. So what's the overall understanding now we have is, there could be some zones in the building in winter which require heating, like the boundaries, and some zones in the winter which requires even cooling. So on average, we might say that on average there is no heating or cooling requirement in the building. But there are some zones, some specific areas in the building which requires heating, some areas in the building which requires cooling. So this analysis using the average values doesn't give us the actual estimate of the heating or cooling requirement. Well, we make some smaller zones. So even if we make even smaller zones like this, we'll have more closer and more closer estimate of the amount of heating or cooling requirement. So I hope you appreciate the concept of zoning and understand how we apply it into the softwares when we do the modeling. Thank you.